Hello, ma'am. Deep Shubhra sir has joined.
Okay, then we'll be waiting 1 or 2 minutes because we said that 5 minutes break. So sorry, I participants. I think wrong feedback link is shared. That is the feedback link of session 10. Okay, we are updating that one. Just wrongly it's written 10. We respond to this. We'll change the form. No issues. Kamulesh is there.
Sir joined, but in list it is not showing at this moment.
Yes, yes, yes.
I have accepted his request twice, but
I think he's having some internet issues then.
internet issue probably.
Let me call him again. Huh? Participants just wait for some time. I think our speaker is having some network issues. We are trying to connect with him. Please wait.
Hello.
Yes, you are audible and visible
Fine,
now.
fine, fine. Yes, yes. I hope I am audible and visible too.
Yeah.
Thanks, thanks. So
Thanks
little
to
bit
you
of
also,
technical
because
issues.
after so many problems, you are finally. Uh,
Yeah. Oh,
okay, so dear participants, we are there on session 10. Our esteemed speaker, Dr. Deep Shubhro Bohra, is there. So it gives me immense pleasure to introduce our speaker um, of session 10. So let me quickly read out his short biodata, though it's not short at all. Um, sir has just a minute. Sir has just mailed me. Just a minute. Yeah. So, Dr. Deepshubhra Guhorai is currently working as an associate professor of CSC AIML department at IEM Kolkata and head of IEM Center of Excellence for Cloud Computing and IoT. Prior to that, he has served for VIT Vellore as an assistant professor senior grade of CSE department after completion his second postdoc as institutional IOE postdoctoral research fellow of computational and data sciences at Indian Institute of Science Bangalore, India. Before that, he has completed his postdoctoral research at Mobile and Cloud Lab of Institute of Computer Science of in University of Tartu, Estonia, Europe, in Radon H2020 project collaboration with Imperial College of London, UK. He is a corporate trainer in Manjarasoft, Australia, and former corporate trainer of BSc Institute, Kolkata. He was a faculty of the Department of Information Technology in Maulana Abul Kalam Azad University of Technology, West Bengal, India. He is former developer of the Center of Mobile Cloud Computing in Maulana Abul Kalam Azad University of Technology, West Bengal, India. He did his PhD and MTech from Maulana Abul Kalam Azad University of Technology, West Bengal, India. His current research interests include mobile cloud computing, edge computing, IoT architecture, blockchain customization, serverless computing, data orchestrations, cloud services template design, and data pipeline with DevOps. One of his research inventions is covered by several media houses like Indian Express, Ajkal, ETV, R+, TNIB, TNIE, etc. He has published 17 highly reputed SCI international journal papers and 26 international conference papers, 10 book chapters, total 51 research paper publications with 10 international granted patents. He has received the International Research Leadership Award as Best Researcher of the Year on the Internet of Things 2020 by the World Research Council and other national awards. He is an associate editor of IT Software Journal and lead guest editor of an SI in Elsevier IoT Journal. Elsevier Computer Communications, and many more. So participants, you can see it's huge biography even. So anyway, over to you, sir. Thanks for joining. I hope our participants will enjoy your session. Thank you, sir.
Okay. Thanks for first of all inviting me and giving me this opportunity. And the next thing is that it's late evening, but the participant is really good. It's
Yes.
188. Okay, fine. So let me share my screen first.
Sure.
So kindly tell me that it's visible or not. Okay. Please confirm that it is visible or
Yes,
not.
it's visible.
Okay. So let me make it slideshow mode. So it is full screen. Slideshow is okay.
Yes.
Okay, fine. So one thing for all of you, those who are participant, and it's a faculty development program. So I am expecting most of the participants are faculty member as well as the research scholars. So you all know I am using single laptop. It's not dual screen. So I will not switch the tab. I will continue the presentation in a single tab. So if you have any question, without raising your hand, just unmute yourself and ask, because I can't see, right? That's another tab. So without wasting the time, so let's begin. So after my introduction, I think this slide is not required, but it's official. That is why I have given. So my topic of discussion for today, it's data pipeline design with serverless computing. See, there is a computing, and I am telling it's serverless. Maybe many of you are here, those who are working in serverless domain and cloud computing domain, and previous 9 sessions, probably you are capable enough to know about the concept of computing as well as cloud computing. So it is a little bit of advanced topic of cloud computing, but as we all know that cloud computing, in the backbone there is a infra, that means infrastructure, that is nothing but the servers. But here in the cloud computing talk, I am telling it is serverless. So a bit confusing, right? So I will clear the confusion, and at end of my session probably there is no confusion about that. If still there is confusion, you can connect me anytime. Okay, so let's jump to the first slide. So as my topic is data pipeline designs, that means the main term is data, then data pipeline, then its design. After that, with serverless computing, that means along with these two, how the proper handshaking is done and how it will works. So nowadays, everywhere you can found data. So we can't imagine every day in number of user of Facebook, WhatsApp, LinkedIn, Instagram, they are posting. So where the data is going, we are not bothered about it, right? So it is somewhere stored. But how it's become computed when you are trying to fetch it, trying to access it, try to use it, right? So this is a concern thing. So that means it should be somewhere from there you have to fetch, right? So here I have mentioned about big data. So just think, we are talking about data and huge volume of data. Is it big data? No. What is a big data? Suppose, just take an example. One 5 years old brother is there and he has his elder brother, and that elder brother age is 7 years. Smaller one 5 years, elder one 7 years. So difference is 2 years. So that smaller guy call that person big brother or elder brother. That means in comparison it is big. So in your computational unit, if a particular volume of data or particular size of data, if it is possible to compute, then it is fine. If you fail to compute with your resources, that means that data is big for you, right? But big data concept is something different. It's a distributed environment is there, huge data, huge computational nodes are there. That nodes can't able to compute that data. That is why it is taking the help of multiple units and forming a distributed environment. And end of it, it is not nothing but a cloud infra. So when I can't able to compute, take the help of cloud. It's public cloud. When we can't able to do again, then scale up. So this is the property of cloud computing. So now let's jump to serverless computing. What is serverless computing? As you can think, I am talking about serverless computing. Just give you, let me give you one example. Suppose you want to create one web application, right? So you have created in your own machine. Where you will deploy? You need a server, and that server should be running 24/7. Will you buy that server with 5 lakhs? No. You are a beginner. You have started new startup company. You are an entrepreneur. So will you invest 5 lakhs? Your company may go in loss. So let's take 5,000 rupees and take a 24/7 server in rent, maybe from AWS, maybe from Azure, maybe from any public cloud service provider, and you are paying 5,000 rupees. You have one server, you have created your own web application, you are hosting your own application over there, and you are earning money from it, right? So for that, you are taking infrastructure as a service, or you can say server as a service, right? So you are taking it from any cloud service provider. But here I am talking about serverless computing. That means it is a cloud computing model where only you have to think about your code. You don't have to think about the infrastructure. That means you can see the diagram. Serverless computing connect with 4 different stuff, that is angular bracket slash. You use this in HTML. There is scripts, there is some analytic dashboard, there is some mobile applications, mobile devices. That means You just concentrate in your code. You just do your coding, where it will be deployed, when it will be deployed, how it will be deployed. If it is not sufficient, how dynamically scale up will happen, how scale down will happen, everything will be taken care by the cloud service provider. So this kind of computing is called serverless computing. So you can read it out what I have mentioned here, and gradually I will come deeper into it. So that means the headache of your server, maintaining your server, installing OS into your server, deploy your application, for that building the environment to develop your web application. You don't have to worry about it. Even 5,000 rupees you are paying for that infrastructure as a service, that also you don't have to pay. Whatever the stuff you are using for your code purpose as serverless computing as a service, that much you have to pay. Okay. So what is the key features? As I am talking about, no server management. You don't have to think about how the servers will be managed. Then event driven architecture. So whatever the stuff you are doing database update, you are doing HTTP request, you are doing file upload, you are doing scheduled task, whatever you are doing, that part actually you have to execute, and rest of the part will be taken care by the serverless service providers. Like when you need more resources, auto scaling will take place. That means using the elasticity property, the infrastructure will rises. That means scale up, scale up, scale up. Volume up, like volume up. You need more volume, volume up, volume up, volume up. You need less volume, volume down, volume down. It's paining, right? Or it's a noise for you. Whatever you are using, based on that you pay as you go, like cloud computing. And fast deployment. So based on your functions or microservices, what is function, what is microservices, I will come later. Based on that, the deployment will be done. It will be ready to deploy. Okay, these are the key features of serverless computing. Then the same part, why we will use, that means there must be some advantages. Lower cost, then simplified scalability, as I am talking about, volume up, volume down. Simplified backend code. So there are n number of templates, you have to edit the code, job done. Improve time of production, because you are not worried about operating system, you are not worried about your infrastructure, you are not worried about your environment, you are only just focusing your coding, coding, coding. So it's increased your productivity, and as it is a part of cloud computing, so it's improved the security as well. Then if there is some advantages, there must be some disadvantages. If there is no disadvantages, no problem, then why we will use this kind of computing? That means there is no purpose of research, there is no uh, place or topic for doing research. If research is concerned and someone is doing some stuff with some computing, that means there is some problem. How to resolve those problems? That will be taken care by the researchers. So here is some problem in serverless computing. What is cold start latency? That means when it will initialize the resources, it will take some time. It's not a big problem. You are just deploying your web application. If it is take some time loading, let take the time. Then limited control. Everything is under control of the cloud service provider. Why? Because that cloud service provider actually managing all of the stuff, right? That is why that cloud service provider must have the control. Then vendor locking. What is this vendor locking? Vendor means AWS is a vendor, Google is a vendor, Microsoft is a vendor. Like that, they are tightly coupled with the ecosystem and the API. Suppose you are taking the service of AWS, but your code is based on GCP. This is not tightly coupled. Suppose you are comfortable with GCP and your code is written with the APIs of AWS. This is not tightly coupled. That means vendor lock-in issue is there. Then complex debugging, as you don't have the control of entire stuff, as the environment is distributed, where which part is running, you don't know. So that is the problem. So little bit problems are there. That is called the disadvantages. Rest all are the advantages. So why we will be used? So this serverless computing. So these are the characteristics. So hostless, that means you don't worry about the server. That is the hosting part where 24/7 hosting will be done. Elastic, you can stretch. Stateless, you don't have to think about in which state it is running. Event driven, when you will trigger, it will start. Then Lego blocks. Lego blocks means there are kids in the home. They have plastic blocks. They taking the blocks, they will create some home, some car, some toys, right? That means there are some templates. Using that templates, you generate your code and execute it. High availability, that means 24/7 it's running, and pay as per use. So these are the characteristics of serverless computing. Based on these characteristics, as these characteristics are there, that is well enough why we will use this serverless computing. Then the popular platforms. So if anyone wants to use AWS, then they have to go with AWS Lambda. If someone wants to use GCP, Google Cloud Platform, then they have to use Google Cloud Functions. For Microsoft Azure also, them Azure Function. For IBM, Cloud Functions, and Netlify. So Netlify is also there. Nowadays, it's coming into the run. But just think about the name of Google, Microsoft, IBM. They are calling about Cloud Function, Azure Function, Google Cloud Function. That means there is a major role of functions. That means whatever you are writing, it is nothing but a function, and that functions are working small pieces, like that Lego blocks. Take those blocks, that means take those function, create your own home or home toy, and start running that toy. In case of computer science, that would be your web application. Now, common use cases. Here, entire my talk, it's with IoT application and data processing part. To do this kind of stuff, when data processing in take place, then we are in the backend, we are actually using REST APIs, right? When we are talking about IoT devices, then we are actually talking about events. IoT nodes are there. They are communicating with the next level microcontrollers. That microcontroller sending those data to the edge server. That edge server is sending to data to the cloud server. But there is no server. It's serverless. Then it should be forward the data to the next level. That may be some function. That function will take that data as an input and process accordingly. So these are the use cases of serverless computing. Now, as I am talking about functions, so what is a function? In cloud computing, there are basic service models. What are these three? Everyone knows. Infrastructure as a service for infrastructure. That means CPU, RAM, storage, like that. Platform as a service. Suppose you want to develop some Android application, you don't have to worry. They are providing Google Colab type platform. Go write your program, execute it, platform is ready. You don't have to build that environment every time. Software as a service, whatever I am doing right now, it is software as a service, right? So I have prepared this PPT in Microsoft Office 365. Previously, it is created in a normal machine, but after some learning, I have created this PPT in Microsoft Office 365 so that we are taking PowerPoint presentation or Microsoft PowerPoint as a service, as a software as a service. Here, I am going to talk about function as a service. That means cloud service providers are providing some functions as a service. When it is a service like tea as a service, biryani as a service, here they are giving function as a service. That means we don't have to write any function. They will already written some functions. We just have to take that function and use it. So just think how they will know which function you will going to use. They don't know. That means there are some templates and they are allowing developers to include individual function or small units of logic into that. After adding those stuff based on your requirement, your full function is ready. Now, if the function is ready and everything is written by you, then what kind of service they are providing? Right? They are providing that template. They are providing where that template will run. They are providing what are the dependencies to run that template. You are just editing that template. Rest of the things are taken care by the service provider. So that is nothing but function as a service. So you can read it out and you can check in the right side. There is a set that is serverless, and inside that there is FAS, that means function as a service. So it is a subset of it. The superset is serverless, and inside that the subset is FAAS. I hope function as a service is bit clear. So now just look at the left side diagram. Traditional. What is the traditional part? We have to, the blue one is front end logic. Then the key lock is security. Then the cube is block end logic. That means back end logic part inside that block. And then you all know that is the database. In the traditional case, you all have to take care. You have to all have to take care by you. That pink shade box, that means the server only given by the cloud service provider. And then you have to write the front end logic. Then you have to write the back end logic. Then you have to take care of the firewalls. That means the security part. Then you have to take care of the database. And then you have to, you can able to execute. This is the traditional part. In the serverless part, client just have to write down the front end logic. That means your required logic part. Whatever the security is there, everyone they have their own developer. They know what are the security policies should be there. Okay, you are taking function as a service. What kind of service you are taking? Okay, front end logic we are writing. Okay, take this function as a service. We are going to provide you the security. Oh, you have to store the data. Where you will store? Okay, no problem. We are providing the database. So they are providing the database. They are providing the security concerns. They are providing the front end multiple logics. From that front end multiple logic, just take one multiple logic. So see, you can check there are 4 front end blocks. From that, you are just taking one and you are just little bit editing inside it. So your function is now ready. So now what is the part? It will be executed over cloud. Clear? This is all about function as a service. Then how this function as a service came to this cloud computing service? See, first infrastructure as a service, then platform as a service, then dot 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 as a service. What is this dot dot dot? Just think, when you are using that infrastructure, they are providing internet also. Otherwise, how will access that infrastructure? That means internet as a service. When you are creating multiple VM inside your account, you can communicate between your VMs, right? That means they are providing intranet as a service. So dot 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 means X as a service or everything as a service. X equals to everything. So after that, this technology came, function as a service. So when function as a service came, if you check the right side architecture, let me explain. Just think about the previous slide diagram, that lower side, how serverless works. You can get the similarity same in the real-time task. So here the bucket is S3 bucket. I am focusing with AWS. Output is the database. It will be stored in Amazon DynamoDB. Then here you are using AWS Lambda. Then you are using Amazon APIs. Just think, I talked about vendor lock-in. That means when you are using serverless computing or function as a service, whatever it is, you have to think about a particular vendor. If you are using AWS, you have to use AWS for every stuff. API, AWS, Lambda for serverless, AWS, DynamoDB, DB, AWS for file storage or anything storage, S3 bucket. From there is one mobile phone. That means your web service call request going to API. That event is going to AWS Lambda. Then AWS Lambda is taking the inputs from to other AWS services and storing that output to DynamoDB and giving that response back to that mobile. So from this small architecture, you can relate this architecture with the last slide architecture little bit. So how actually serverless and fast is working together. Why? Because fast is nothing but a subset of serverless computing. Now, what is microservices in serverless computing? When we are talking about function, then inside that we will use microservices or some building logics, small blocks. That small blocks are nothing but microservices. From micro, you can imagine it is not a long service, it is a small service. If it is small and it is providing service as a function with respect to function as a service, that means it should be independent. Are you getting my point? That means it should be independent. That is why it is written small and independent services is microservice. And event driven, I am talking about long time event. What is that? Serverless microservices often triggered by the events such as API calls. That mobile phone and it is connected with API gateway of AWS, that part. Loose coupling, that means it's not tightly coupled, it's loose, it's not dependent, it's independent. When a microservice is talking about, that service is self-sufficient enough to serve. At the end of my slides, when I will show you the use cases, then you can relate this stuff. Then statelessness, right? What is statelessness? Just think about, I talked about this statelessness in the characteristics of the serverless computing. Serverless functions are stateless, meaning that don't retain any information between invocations. When it is called, when it is done, it's done. Like waiter in a restaurant. Suppose you visit one restaurant, you order some food, you have that food, then you paid the bill for that food and you left the restaurant. Is that uh, particular waiter just save in his brain or her brain that who came, what is his name, what is his wife name, what is his son name, what is his daughter name? They will not bother about it, or they will not store it at all. That is why you can think or you can relate restaurant waiter with this serverless statelessness classification. Okay. Then auto scaling, I already talked about. If a microservice is running, it need more infrastructures, then automatically scale up. If the microservice is running in high cluster, but it's not required that much, to make it cost efficient, just reduce entire stuff, volume down, automatically scale down is take place. So this is what microservices works in the concept of serverless computing. Then just have a look here how a basic framework of serverless computing works in event driven processing, right? Just start looking from this left hand side corner. I have taken this architecture from a particular paper. That paper is referred in the below. So see, there are a person, another robot is there, there are some IoT devices, bands are there, chips are there. Why it is there? That means we are fetching data from those IoT devices. Then that data, I mentioned here data pipelines. I will come. Just look into this. After some time, you can relate it. We are fetching the data from IoT devices. Then where that data is going? The data is going to the event gateway, right? Then that data came to that event gateway. Now that event gateway have to forward that it to next level, but it is serverless computing. As it is a serverless computing, that means you need some function. So here we take function 3 triggered, function 1 in the queue after function 3. Like that, the schedule, the queue, the waiting queue is formed. First function 3, then function 1. So whatever the data is taken, that may be a get function. That get function is taking the data from the IoT devices forwarded to event gateway. From that event gateway, the function F3 is fetching the data. And maybe function F4 is for processing the data, but it is scheduled. You take in these two function services. It is scheduled. That is why that schedule line is there. When a scheduler take a process to processor from RAM, The operating system concept, same here. F3 will be taken and it will be given to the function container, right? Function container have many other functions, and there are some function code store already compiled, right? You taken that function as a service F3, code compilers have that compile code. They are actually completed the entire function with that given data inside that container after loading from that code store. Then after execution, it is providing that result to execution result. Now just think what you have written. You have given the data only. Function F3 is already there. Function F3 compile code is already there in the database, function code store. Then function containers are there. They are doing permutation, combination, whatever the state laws and whatever the stuff is required. And then after doing everything, it is giving the result. So you are just paying for using this kind of facilities, and little bit of business logic, and rest of the part is taken care by the serverless computing with FAAS. That means function as a service. Now, in the last one, I talked about from data pipeline, right? At the bottom part. So now you have to know what is data pipeline, right? So just look into the pipeline. I have not drawn that. I have taken from Google only, but it is very, I like this one. See, there are data collection. It may be batch or stream data. Batch means you are doing private tuition, batch students, batch after batch you are delivering your lecture. Maybe streaming data, like dynamically data is coming real time, that may happen. Then data ingestion, then data preparation, that means that cleaning part, then data storage, then data governance. So these are the stuff are related with the data. So what is a data pipeline is? So data pipeline is a series of process or step to move, transform the process data as I have written. But how it actually created? You can use Amazon data pipeline. You can design your data pipeline over there. You can use in your own machine Apache NiFi. That is an open source tool developed by Apache. It's called Niagara Files. Files, nothing but data. How it works? There are multiple processors. CPU processor? No, it's hardware processor. But in the Apache NiFi, it is software processor. Processor means inside that software processor, some process are actually running. Like, as I talked about, function, get function, HTTP request function, HTTP response function, then MQTT function. MQTT is a protocol for IoT, message queuing, telemetry transport. I will come to that. Then publish something, subscribe, like your YouTube channel subscriber. Those who will subscribe, they will get that information through that get functions, put function. So there are n number of functions. So 200 plus processor already developed processors are there. So what you have to do? You have to choose proper processors. You have to connect that proper processors, and you have to create one data pipeline. If you create that data pipeline, for suppose you are creating one data pipeline for file storage. So what it will do? Suppose you have created one S3 bucket. Just think about a storage area, and another storage it is in your machine. When you will execute that pipeline, it will take folder files from a folder from your local machine or your laptop, and it will store automatically to your S3 bucket account in AWS. That means if you log into your Amazon S3 bucket, inside that bucket you will check that file is available. Now just think, suppose you have written one code, that code is running on the web, but your IoT device is connected at your home. How it will be triggered? So first, IoT device will collect that data and stored into the local machine a particular folder. And you have created and run one data pipeline, and there you have mentioned, okay, if any file in every 1 minute you found in that particular folder, just send that folder to S3 bucket. Now why you are sending that folder to S3 bucket? If your data is available in public cloud service provider infrastructure, that means it is live. That means your web application can fetch that data from S3 bucket and process. So if you have internet, you will get the notification what actually happening into your home. So just you think your data in your laptop folder to make it accessible in the cloud service provider S3 bucket. In between, who will work? Actually, this data pipeline is doing all of the stuff. And how you have prepared that pipeline? Using the processors of Apache NiFi. That is predefined, already system defined processors are there. You are taking that processor, are doing a drawing, nothing but a drawing. That drawing code actually doing all of the task. So this is all about what is data pipeline is. Then the key component of a data pipeline. Already I talked about data source. Just think about your local laptop folder. Data ingestion, how it will take from periodic loads. Periodic load means after 1 minute, send, it will load and send. Then processing, how it will filter. Here in the last example, I am not filtering. Suppose you are in Apache NiFi, what the file you are taking, you are just opening that file, then you are cleaning that file. If this kind of process you are doing, then you are storing to particular S3 bucket. That also you can do. So this is came under the processing part. Then storage part, see, you can check the data lake. A lake with full of data, that is why it is called data lake, like S3, Amazon S3 bucket. And then I am talking about orchestration. So what is data orchestration? How that pipeline will work? For that, there is a tool, Apache Airflow. But we have developed another, what should I say, data orchestration platform. So to understand those stuff, you should have the knowledge of serverless. I hope those who are really listening, those who are listening attentively, they can able to get some idea of serverless till now. Then function as a service, then data pipeline, and how the event driven stuff is actually working. Those who are actually listening, I think they got some idea. Then I will came how the orchestration will take place. Then delivery and consumption. If it is delivered to the server, from that you are actually get notified by the push notification of your IoT application. So your entire stuff is done. But the entire backbone is nothing but your data pipeline. So data pipeline is very, very important, as well as the function as a service also. So types of data pipelines: batch data pipeline, real-time or streaming data pipelines, and hybrid pipelines. Batch data pipelines I already talked about. Process data in chunks, a particular schedule interval, like loading sales data from a ERP system into your data warehouse. Overnight, it will be synced, processed. Just think about the salary. Suppose 800 faculty members are there in a particular institution. So from the bank, they will send one by one? No. They will take a file where your account number is there, your IFSC code is there. They will do a batch processing. One by one, it will done. Right? So this is called batch. Real time means whenever you are doing, at that time, it's affected. Suppose monitoring website activity, updating the dashboard real time. Suppose you are doing right now. Suppose I am showing this right now. In the real time, you can see in your own machine, right? Then hybrid data pipeline. So it is a combination of both pipelines, like batch data pipeline and real-time data pipeline. If these two type of pipeline are working together to create a better data pipeline, then it is called hybrid pipelines. Now, common tools for data pipelines. Okay. So there are some different tasks. So based on that different task, the tools are different. Ingestion tools, processing tool, orchestration tools, storage system, and visualization tool. So I hope many of you have heard about Apache Flume or Apache Kafka, Google PubSub, Nixis, Amazon. So what it will call? Ingestion. That means there are huge data. From that data, how we will fetch? So Apache Flume is very well known stuff. Suppose someone is tweeting every day. From that tweet, how we will predict the emotion? Today is IPL game, who will win? From the tweet, everyone is thinking whatever they are thinking, they are posting. Based on that post or tweets, if you want to fetch those data, how we will take that data? In that case, you have to use Apache Flume. So processing, Apache Spark or AWS Lambda. Already I talked about. So AWS Lambda is nothing but a tool for serverless computing where actually all the functions of processing is there. You have to use it. For orchestration, Apache Airflow. You can do whatever you want. For storage, AWS S3. But you can say why you are talking about Amazon. For that vendor locking concept. When I am talking about Amazon, we have to tell about all Amazons. Then for visualization, nowadays everyone know Power BI and Tableau is there to show the data in proper visualized fashion. Next. See, I have written with AWS. So overview of a data pipeline. Just think you have created one instance, and in that instance means one virtual machine. In that instance, you have to install host operating system. You have installed host operating system. Top of that, you have installed Apache Niagara files. That is nothing but that data pipeline designing tool where you have 200 plus inbuilt processor. Using those processor, you can prepare your pipeline. So here, see, there is a S3 bucket. From that S3 bucket, you are taking the images and get the list from the pipeline. And you are sending that images to pipeline 2. And that pipeline 2 in another system. Instance 1 is a system, instance 2 is another system. And both of the system has their own host OS. And both of the system is running with Apache NiFi. Otherwise, the pipeline will not run. If you have created pipeline, you need a platform where to run that pipeline. To design that pipeline, you need Apache NiFi. To run that pipeline, you need some platform, that is Apache NiFi. That is why pipeline 1 is sending images to pipeline 2, and pipeline 2 is nothing but a lambda function. What it is actually creating? Taking that big size of images and creating the thumbnails. You know, in the phone, whenever you are taking some pictures, if all the pictures are removed, the thumbnails are still there. That is the thing, it should be created in a small resolution file. So here, fast machine or fast pipeline is taking images as an input and forwarding that images to pipeline 2, and that pipeline 2, with the help of function as a service from AWS Lambda, it is creating small size of that high resolution picture as a thumbnails in KB and storing that thumbnails using that pipeline 3 into another S3 bucket. So just think about one bucket, that bucket have high resolution picture, and the next bucket have thumbnails. You just save one file in the high resolution bucket, it's automatically, without any kind of human intervention, the thumbnail is created in another bucket. It's interesting, right? So how it actually happening? In the backbone, the data pipeline is working. In the backbone, serverless computing Lambda function as a service is working. And in the Lambda function, you are using microservices. In the Apache NiFi, you are using microservice based processors. And as a whole, you are actually orchestrating it for the first time. When you are designing entire thing, you have to run. If it is running, then only the execution will take place. Otherwise, your code is your code, right? Nothing will happen if you write, not execute it. If it is executing, that means a process in execution, that is called a program, right? Sorry, a program in execution, that is called a process. So you have written a program, when it is executed, so it's become a process, and that process is running. When the process is actually running, then the entire stuff is happening. You have created the entire backbone. So to run the entire show, you need a orchestrator. So here the orchestrator came to the picture, right? So till now I am talking about serverless computing, function as a service, then Apache NiFi for data pipeline, rest of the things. Now orchestrator came to the picture. So here we are using a language or a framework that is called Tosca. So what Tosca is? Now, what is a Tosca? Tosca stands for Topology and Orchestration Specification for Cloud Application. Maybe many of you, those who are listening, you are thinking, what are the technologies you are talking about? We have never even heard about these terms. Believe me, many person never heard about these terms. Why? That is not our fault, because these all technologies are actually developed in other continent like Europe. They are developing every day, and they are enriching it, and whatever they are making, they are using it, right? So they are facing the problem and they are upgrading it. So when I was in Estonia, University of Tartu, that time we have started using this cloud application. So it is topology and orchestration specification for cloud application. So this Tosca model actually designed to define, deploy and manage cloud application services. So what it will manage? It will manage a cloud service. What it will define? Define a cloud service. What it will deploy? It will deploy a cloud service. What it will manage? Manage a cloud service. That means whatever the stuff Tosca is doing, whatever this orchestrator is doing, you have to think about service models. So whatever it will do, it will create a service. Got it? So how it will create a service? In the backbone, data pipeline is there. So when the service model is designing, then data pipeline working as a backbone, function as a service working as a supporting hand. Then processor of Apache NiFi is used for creating the data pipelines. As a whole, they all are working to create the Tosca service model, right? So in the Tosca service model, what are the main things? Service templates. So that means there are some structure where the behavior and policies of a application it is written, that is called topology template. How it is looks like, I will show you. The plans, how the workflow or how the lifestyle of a particular service model will work, that is defined in the service template. Then node type. Node type nothing but a softwareized stuff where all of the service part of that particular service is written. So in the node, so computer, laptop is a node. Just think you are creating one node, it is softwareized node, like software defined stuff. And that node are connecting with another node with softwareized manner, that is software creating software defined network. So node type is one part. Then relationship type. Like one example it is given, hosted on. That means you created one node type with one service template. Service template is the first one. You are writing one service, editing one service template, creating one node type, and where you will host in your local machine or cloud server machine, that will be taken care by the relationship type. Then policies, how scale up, scale down will be happen, how security will work, how quality of service will give, that will be taken care by the policies. Then artifacts. Artifacts are nothing but files or script, right? Why it is required? How deployment will take place, what are the configuration is required. So you have to write all of the stuff in XML and you have to upload that XML in the artifacts part. And then capabilities and the requirements. So you are requesting for hosting. Is that hosting environment is ready? Hosting capability is there. That part will be taken care by these capabilities and requirements. So these 6 things are required to design a Tosca service model. If you have these 6 things, a Tosca service model is ready. So if a service model is ready, that means you can execute that service model for automation purpose. So how it actually happens? It's actually happen with the code of Ansible. Ansible and Tosca language are related. Ansible is used for DevOps coding. That means for automation part. So this is how it looks like. It is a service model using Tosca. So in the right hand side, you can check here we are actually creating one load balancer. Huge load is coming to a particular server. You are just distributing that load. That is called Nginx load balancer. So if we are creating this kind of service, left hand side you can check one VM is there and running Nginx. And top of that you have hosted one site. And then that Nginx is connected with the Nginx load balancer Nginx LB with connect to LB. That means whatever the load is coming, traffic is coming to that site, that is going to Nginx, and that Nginx is forwarding to Nginx load balancer and balancing through the next VM. It is the second one, Nginx VM load balancer. Like that, if you want to do the entire stuff, then you have to write. If you want to do the entire thing automatically on the fly, you are sleeping, everything will be taken place. If huge traffic came into your website, so then you have to write this kind of Tosca models if you want automation. Then you have to define all of the stuffs I have mentioned, the 6 things. for writing one service model. If you can able to write, then it will work. So if you check this part, that Nginx load balancer part, we have written image CentOS 7, then M2X small, it is a flavor. That means what is the size of the VM. Then what is the key file. So this is a key file name we have created, and where it will be created is OpenStack. That means private cloud environment it will create it. Like that, the entire stuff will be taken place. It is not a easy things. In one lecture in 5 minutes you can't able to understand. It's a huge thing, but if you get some glimpse of the idea, then if you start studying or reading, getting want to do a research on it, then only you can learn. Then we are talking about so many codes. So how to make it visualize? To visualize the entire Tosca service models, we need Eclipse Winery. Eclipse Winery is a graphical tool, web-based modeling tool or framework for creating Tosca service templates. I'm talking about service template. Inside that, every services and the plans are there. So that is service templates. You can create in a user-friendly manner, easily design it using Eclipse Winery by drag and drop. Whatever the code I am talking about in the last page, you can do with drag and drop. So this tool is required for creating that with drag and drop. And already I have talked about many things with for Apache NiFi, how Apache NiFi actually works. There are a number of processors. This is open source data integration and orchestration tool to automate the flow of data from your local machine to S3, as I am talking about. Like you are giving the image and it is creating thumbnails like that. So how it actually working? There are n number of processor. You are just drag and drop that process, and you can see it is running top of a Docker. You can run top of a machine. You can run, and there the right part is looks like this. So processes are, you have to drag and you have to fill the forms with the information, and your job is done. Your data pipeline is ready to go. So now the main research centric stuff came to the picture. So I mentioned use case solution design and solution designed and developed by me. So it is a use case solution for a particular problem and designed and developed by me. So the first one. So here you can check some blocks. You can check my name also. The password values Deep Shubro Guhora, it is mentioned in the encryption part. The left hand side encryption, the right hand side decryption. So what the problem is? Suppose it is a problem of IoT. In the IoT environment, if you use MQTT protocol, then you are transferring messages from one node to another node. So how make that message secured? So see, in these blocks are nothing but node types. I am talking about nodes. So these are the node types. So create that environment, create that secure environment. I need 7 node types here. So what it actually creating? So first node type I have prepared with that. These 7 node types are designed by me. And using that 7 node types, I am actually creating this solution. So how I have created that node type? Suppose encryption. So first I have created the data pipeline for this encryption. How the encryption will take place. Then decryption. How encryption and decryption will take place and will be work together. So I have created one data pipeline for encryption, one for consume MQTT, one for publish MQTT, one for MQTT broker, one for Apache NiFi, one for OpenStack, one for data encryption, decryption. Sorry. So these 7 node types I have prepared with the help of that Tosca service template in Eclipse Winery. So it is looks like this. After creating that, we are actually drag and drop entire thing here and connected the relationship type with hosted on, connect to local, connect to local NiFi, like that. So what actually happening here? So here one message is consumer. Suppose you are posting something into your YouTube channel. Here also the consumer of MQTT will consume the entire data from the MQTT broker. So there is some publisher. So that is the publisher MQTT. And where the MQTT broker will run? MQTT, to run that MQTT broker, you need some server. That server is created in the top of OpenStack. In the top of OpenStack, one server is created. That means local private cloud. You have created that private cloud environment with OpenStack. Inside that VM, you are running one Mosquito broker, and top of that OpenStack, you are installing an Apache NiFi so that you can run these 4 data pipelines: encryption, decryption, consume MQTT, and publish MQTT, right? So what it actually doing? Publish MQTT, publishing messages through that data pipeline. Consumer is consuming, but while it is publishing, encryption will be happening. Well, when it is consuming, then decryption will take place. So we have created this entire design and orchestrated with the orchestrator. Then the entire thing is running on the fly, and all of the stuff is happening automatically. So to make this entire problem so easy, we are creating that node types, and it's available in GitHub also. If you want to use, you can install and use for your research purposes. The next problem is that is consume Azure. It is with Microsoft Azure, as I am talking about. When AWS, when Azure, because serverless computing and fast has some dependencies, right? So what here we have created that OpenStack same. Why OpenStack is required? We have to install NiFi, Apache NiFi. If Apache NiFi is not installed, that means hosted on. You can check this Apache NiFi hosted on OpenStack. OpenStack means you are creating one VM. That VM with CentOS. You can check that Azure Blob, data pipeline deep. You can check my names also. So what I am doing in this problem? That problem I am talking about, your laptop have some data. Periodically, from the batch by batch, it is forwarded to another particular S3 bucket. If you do the same thing in Azure, that is called Azure Blob, very large object. That is why it is called Blob. You are publishing sub blob through data pipeline, through Apache NiFi. It is going to be consumed to the consumer end, and that consumer end part is actually connected with your web application, so that your web application get the data in your dashboard. So this is another solution. The next one is for SFTP, Secure File Transfer Protocol. So Secure File Transfer Protocol is already there, but how you will implement that? So you can check in the left hand side. One path is upload, and the another path in the right hand side, it is download. So here again we have taken that node type OpenStack, another node type NiFi. Top of that OpenStack we have hosted on that NiFi, and that both of the pipelines are connected. Both of the node types of consume SFTP and publish SFTP is connected with NiFi for uploading and downloading the stuff. And the username is the port is for consumers 32, for publisher 42. You can check the host name, private IP addresses are given, password is given. You can ask why it is clean text. No, it is not clean text. It is already encrypted with that encryption data pipeline. That node type I have created, encrypted. So like that, everything will be taken care, and secure file transfer from one machine to another machine will happen in your private network. So till now you have checked OpenStack. Top of that OpenStack, I have installed Apache NiFi, then I have worked. If you check OpenStack in this kind of environment, that means we are using private cloud infrastructure. That means it is organizational network. Here I have created something beyond our research part, and it is already something huge. Single one node type, that is elastic map reduce. I have given the node type EMR activity. So it is actually tagged with AWS. How? So you are designing, till now you are designing data pipeline with Apache NiFi. Now we are designing data pipeline with Amazon Web Services data pipeline designer is there. Using that, we are creating one node type, this node type, where what will happen? It will create a elastic map reduce cluster. It will take the big data input. Just imagine in the first slide I talked about big data. It will take that big data input. It will process that big data. You don't have to think about how the infrastructure, how much infrastructure is required, how the worker node and the master node will be created, how this worker node and master node will be connected, how this worker node and master node will communicate between each other, how that worker node and master node will distribute the load. Each and everything written inside this small box. We have designed that. I have created this. You just drag and drop, fill up your details and execute it. It will automatically create a cluster in your AWS login, whatever you have providing here. So inside that, it will create a cluster. It will take the input from your data S3 bucket using your data pipeline and do the big data analytics part. So this uh, node type is particularly created for big data analytics part. So these four use case solutions I have mentioned here. I know it is very complex things to understand in this 1 hour lecture, but I am trying to give you the glimpse of it so that you, if you have some interest, you can get something idea. After that, you can work on it. Then there are n number of research problems. So I have mentioned few. So when you are designing data pipeline, how to optimize that pipeline? This is a research problem. Then I talked about stateless, stateful stuff of serverless environment, how to manage that state. Then latency in throughput, how you minimize the latency, that means the delay, how you minimize that. Then how you will increase the security privacy issue, how you will make resistant your recovery of your serverless data pipeline, how you insurance the fault tolerance in the distributed environment. It's tough. How you will monitor the entire stuff because it is happening in distributed mode. How you will control the debug, how you will debug. So this is a problem. Then cost prediction. You are using so many functions, but is it cost effective? That you also you have to think about it. Then data consistency is a problem across the distributed environment. Then resource allocation, when the serverless stuff is happening, as I am talking about OpenStack, NiFi, you have to run that NiFi, you need an environment. That is why you need one OpenStack platform, you need one OS top of it, like CentOS. So these things, that means one virtual machine is required. So how you will allocate that resources? And the last one, the integration issue. So how you will integrate the whole stuff? And I have talked about so many technologies. It is very tough to integrate so many technologies together. But here, what I use case I have shown to you, all the technologies are integrated together. So this is all about, and I have taken I have just mentioned the basic references. These references are very useful. So using that reference, you will get the AWS docs, the white paper, everything is mentioned over there, what, how you will learn. Then data pipeline, if you want to use Azure, then GCP, for GCP, how the data flow guide and data pipeline guide it's given. If you want to install Apache NiFi, how you will install, how you will download, what command you have to write, it is given. If you want to use the product Winery, Eclipse Winery, how from where you will use, and the Tosca, the entire stuff of Tosca is given over there. This is all about the references from where I have prepared the entire stuff. And most of the use cases and the things, it's not available here. You can check my first postdoc University of Tartu Radon project. You can search Radon Horizon 2020 project for all the details. So if you go to that GitHub link, you will get all of the use cases I have created. You can check my name over also in the contribution section, and you will get it, and you can use it for your research purposes if you are really interested in. Thank you very much to all of you for your kind attention.
Deepshu bro, I don't know whether you have noticed or not. There are so many participants who are already giving reactions on your presentation.
Okay.
I think
Okay.
as a presenter, it means a lot. These are
Okay.
popping
Okay.
out. I think there are various messages I have received that it's a nice presentation, because from our end, you can see it's popping out constantly.
Okay.
I think I don't have to say anything after this.
Okay.
Such a nice presentation, such an informative presentation. You can see constantly the reactions are popping out.
Okay.
I don't know
That's
whether
good.
you are able to see or not.
No, no. So I can't able to see because actually I first mentioned that when I am presenting, I am in a different tab.
Yeah, if
So if
I
they are
don't
giving the
know,
reaction, I can't. Yeah.
Kamalesh sir, is it possible to unmute the participants at a whole? I think there are so many participants who are eager to tell. It's a like wonderful presentation. Definitely, indeed, it's like I think right now it's around 200 participants are sitting at
Right.
a time,
Right. Right.
and
Right. Right.
I have received so many messages as it was a very nice presentation. It's informative presentation. And
But it's
your
very
effort,
complex.
the most
It's very complex.
importantly, the effort you have given. Whenever you called me in the evening, I was also in very tension that I don't know how you'll manage. But finally,
So this
it's
is nothing but
awesome,
the
awesome.
professionalism. This is nothing
It,
but the professionalism. We are the professional guys, right? We have
yeah,
to
right,
maintain the
right, right. Even I
professionalism.
am a big fan of yours because you are quite junior to me, but still
Right.
I think I am a like a big. It's nothing to say. When I was not able to even like go out of my place in my. I was there sitting in my seat only for this entire presentation. It was really awesome. Kamalesh, is it possible to unmute the
To
participants?
unmute the participants, I
Yes,
have
they have
to
to raise your
unmute.
hands.
Yeah, otherwise I have to unmute one by one individually. So it would be
Participants, if you
better.
have to share anything to Sir Deepshubro sir, you can raise your hand, because I think as a presenter, it's like you have already shown your reactions. If you have to share, please raise your hand. Your effort was tremendous.
Thank you very much for the this thing when
I maybe
actually
I'm going informal in this case, but
no,
I
it's
think
it's okay, it's okay, no problem at all. But that time when I lost the entire
yeah, yeah.
PPT I have prepared with 3 hours of effort, so I just thought how I will manage. So let's try. So while I am driving from my college to home, that 1.5 hour, I am just thinking how to manage, how to manage, how to manage. So as we are the engineers, somehow we have to manage,
Yes,
right?
yes, yes.
So
We
we
are
are
manage
just doing that.
masters.
We
We
are
are
the
manage.
manage
But
masters,
thank you.
right?
Actually, Devashi sir has given me your name.
Right.
So in that case,
Please give the feedback to sir also.
yeah, sure. Sure, definitely.
Right, 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 right.
Uh,
So if anyone have any question, you can ask. Otherwise, it's already late for all of you, and I am able to see 194 till now.
yes, yeah,
If I
till
am the
now.
participant, I will left long back.
No, no, no. It credit entirely goes to you only.
Thanks a lot. Thanks a lot. It means a lot for me.
Okay, so good night.
Good night,
Rest of the
everyone.
formalities we'll be doing tomorrow. Ah,
Okay, okay.
okay,
Thanks for
so good night.
cooperations. Okay.
Yeah,
Please
thanks to the
share the PPT
participants.
with the
Sure,
participants.
sure, sure. We'll do the
Yes.
needful.
If they have
Sure.
any issues, they can directly contact me. I have provided my WhatsApp number and the calling number and mail ID also. Whatever they
Sure,
will wish, they can do that. Okay.
sure. We'll be doing the
Thank you,
needful
everyone. Good
and
night. Bye
yeah,
bye.
good night. Good night. Okay, participants, we are sharing the, so that's the end of the day and tomorrow will be starting at 2 o'clock. I'm sharing the feedback form of Deep Shubhro Gorai, Dr. Deep Shubhro Gorai. Please do fill it up with your registered mail ID. Good night, everyone. Thanks a lot for all sort of cooperations. Kamala sir, you can end the meeting.
Yeah, I'm going to close this